Welcome back. In this video, I will show you how to write code in C for inserting item into priority queue using array. In the previous video, I have given you the idea how to implement the priority queue using a 2D array. So here you have the array where this side will denote the array index and this side will denote the priority numbers. So the rows here will act as priorities. Now here we have two more arrays, so these are linear arrays. The name of the first array is front and the second array is rear. The cells of these two arrays can be accessed like this. Front 0 for the 0th cell of the front array and rear 0 for the 0th cell of the rear array. Now what will be there inside these cells? For priority 0, the front 0 will carry the index of the first element of the items with priority 0. Rear 0 will carry the index of the last element with priority 0. Similarly, front 1 will carry the index of the first element with priority 1 and rear 1 will carry the index of the last element with priority 1. See here, 66 is the first item with priority 0 and is located at the 0th cell. 32 is an item with priority 0 and is located at cell 1. So, front is at 0 and rear is at 1 for the priority 0. So, here you write 0 in front 0 and 1 in rear 0. Now, for priority 1, the front is here at cell 1 and rear is here at cell 2. So you write front 1 is 1 and rear 1 is 2. For priority 2, both rear and front are at index -1. Of course, -1 index is not there in an array, but since there is no element in this row with priority 2, so we set rear and front to -1 like this. For priority 3, the front is at cell 3 and rear is at cell 5. So right here 3 and 5. And for priority 4, the front is at cell 0 and rear is at cell 5. So here you write 0 and 5. So you can see from this front array and rear array that for a particular priority, where is the first element located and where is the last element located. Now I will remind you one thing. For insertion in a priority queue, we will follow the algorithm as we have learned before, that we have to take care of the new position of the rear, because rear will act as a guide of the proper location for the new item. On the contrary, for deletion from this queue, we will find the new position of the front here as we have done before in conventional queue. So for insertion, we have to take care of the rear, and for deletion, we have to take care of the front. Let us write the code here. We have taken priority queue 5 by 6. That means there are 5 rows and 6 columns as we have used in the example in the previous slide. We have taken front 5 cells for front, 5 cells for rear. We have taken I and J. We have taken data for the new data to be inserted. We have taken a priority variable. We have taken a choice variable here for deciding the type of operation selected by user, whether insertion or deletion or display or exit. All those things will be controlled by this choice variable. And we have a priority queue call is a variable. Of course, you can see this is a long variable name I have used here. Later I will show you why I have used this kind of name here. Okay. And the last variable here is there is data. If it is 0, then it is false, and if it is 1, it is true. This is our 2D array for storing the data. and these are the two linear arrays, front and rear. And we initialize these two arrays with -1, right? So we run a loop here to initially set the front and rear to -1, so it will look like this. So for each row, or for each priority, you say, rear and front is at -1. Okay. Next, you will run a while loop and you provide this message that 1 for adding new data, 2 for deletion, 3 for display, and 4 for exit. And you store the user's choice in the choice variable. And if the choice is 1, then you ask the user to provide data and take the data in the data variable. Also, you ask the priority of the data and store the priority inside the priority variable. Okay, so you have the data and the priority from the user, right? Next, you see here, in this slide, I have given you a snapshot of some data that are there already inside this 2D array. Now I asked you that start with a vacant 2D array. Now you should notice here that there may be several addition and deletion operations. And for that, your 2D array may look like this. So in that case, your insertion and deletion should be handled in a different way, right? So we start from here. Now before going into the coding details, I should remind you again that for insertion operation, you should find out the rear's new position, because rear will act as a guide to find out the proper location for the new data. Now, this code is for a specific priority, right? Suppose the user has given priority 4 with some new data. Now you come here. See, the priority 4 is looking like this. So, in the front array, for priority 4, you have the 0, and in the rear array, for priority 4, you have 5. So if this is the situation, you can clearly see that the row is full. So the condition will be if front priority equal to 0 and rear priority equal to 5, or there may be another situation when your specific row will be full. That is, when front priority is equal to rear priority plus 1. So here you see the front priority here is 3 and the rear priority is 2 for the priority 4. So it will look like this. Now how it happens that front has gone beyond rear? In one of our previous videos on queue, I have explained how it goes like this. Those who missed that, for them, I will give you a small demo. You take the example of priority 3. So here is your front and here is your rear. Now when a new data comes up, this rear moves from here to here and the new data will be there. Still there are 2 vacancies more. So you can increment rear over here for inserting another new data, and you can move your rear over here for inserting another new data. So what do you see? Rear is standing at 2 and front is 1 index beyond rear, that is at 3. And it is clear that this row for priority 3 is full. So you write print overflow, you mention the queue priority over there and return, right? Now suppose the user has given priority 2. So see the figure here. This is the case, that it is absolutely empty. That means for priority 2, front is standing at -1 and rear is standing at -1. So front 2 and rear 2 both are holding -1. Then you write if front priority is equal to -1, then you set front priority and rear priority both of them to 0. Like this. So you see that front 2 and rear 2 both are standing now at the 0th cell. Suppose user has given priority 3. Now come here and look at the figure. This is priority 3, where front is at 3, that is, front 3 is at 3, and rear 3 is at 5. So the figure goes like this. Now a few seconds back, I explained to you what you should do if the rear is standing at the last index and there is a vacancy in the first index. So you should bring rear 3 from here to here. So you write, if rear priority is 5, then set rear priority to 0. So this becomes 0. So here you got the new position of rear. Suppose user has given priority 0. So in the figure you see, in priority 0, front 0 is 0 and front rear is 1. So front 0 is here at 0 and rear 0 is at 1. Now this is the else part where the row is non-empty, that means there is data, and front priority is not -1, right? And rear priority is not 5, right? So this is the condition which is indicated by else. So what you should do? Plain and simple, you increment rear from the first index to the second index. So set rear to rear plus 1. For priority 1, the same else part will work, because you see that in priority 1, front is here and rear is also here. So there is enough space for getting rear to rear plus 1, right? So the else part for this data snapshot properly works for both priority 0 and priority 1. Since we have found the proper location of rear, it's time to insert the data into that location. So you write priority queue, this is the name of the queue, and the first index will be decided by the priority. So this is a row number, and the second index will be decided by rear priority, because rear priority will show you where to put the data. This is the coding for insertion of data inside a priority queue. In the next video, I will show you how to delete item from priority queue. Thanks for watching and take care.